All right, let's move on to all those application concepts. So listen for this one, yeah. This question in here, this concept in here, don't do anything. Just put down a pen and use your brain to analyze this first. I can tell you if this question, this concept come up in exam, at least 70% of your friend or you will going to lose 1 mark. Okay, it's not a hot topic. It's not a common topic. It's not every year. Like, what's wrong? Let's find out. Okay, I give you 3 diagrams in front of you. Let's say the x value in here is 1. This is 1. This is also 1. Don't do anything. I just purely listen move first. I will give you time to copy. Can you tell me the domain for these 3 graphs? The domain for the first one on top of your head. Can you tell me what's the domain? I believe you will say R. Agree? Yeah. The domain for the second one, make sure you use your brain. You also say R. The last one, the domain, you say R except 1. Agree? Yeah. No big deal. And then the second question I'm going to ask you is, tell me, is it a continuity function? What does it mean by continuous? You can say join together or travel the whole graph without lift up the pen. You can travel the whole graph without lift up, like this one, I have to lift up the pen. So is it continuous? No. The next one is a continuity function? Yes. And the last one is a continuity function? I will say no. Yeah, don't tell me, hey, I can work like this, and circle and do like this. That's a hole there. Doesn't work like that. All right. So first thing I want to mention is what I'm trying to say. That I want to say is do not use your domain to judge whether it's continuous or not. You can see these 2 both have domain R, but this one is not. This one is yes. Okay, understand? Yeah. So how do I know whether it's continuous or not? You can use, like, if you got a diagram, you can visualize what's going on. But then I'm going to give you one example in here, these questions. This time, I don't have a diagram. And do I need to draw a diagram? No. This question asks you, state whether fx is a continuity function. Is it continuous? So without a diagram, or like this one, how come yes? Because same x, they have same y. That's why they join together. Agree? Same x, they have the same y. Yeah. So to test whether it's a continuity function, so what you can do is, 1. I just sub 1 into the first equation. I got 0. Sub 1 into the second equation. Can you see they're not the same? Therefore, fx is not a continuity function. If this is what you do, you are those 70%. Sorry, you lose 1 mark. All right, anyone tell me why? What's wrong? Whatever I'm saying, the whole thing makes sense, right? But what's wrong? Why I'm the majority of 70% of the student, I lose 1 mark? What's wrong with it? Yes. Very good. Okay, your theory is correct. I sub the x value into the equation to see whether the y value is the same. But however, the presentation, you're wrong. Because technically, 1 cannot go into this equation. Then what you need to do, the theory is fine. The concept is very basic. The most difficult one is you need to bring out something by yourself to show it's not continuity. Bring out what? How do I sub a number without making that value equal to that number? One word. No one? Good. Okay. That's why you have to bring out limit by yourself when you see this question. You need to know that, okay, this is wrong. I got an angry face. Bruh. So the proper way to do it is limit x approaching to 1 to the power of negative. And you say, what do you mean by 1 to the power of negative? You can think about number line. 1 is here. I can approach this side. I can approach this side. If I approach from the left-hand side, it's 1 to the power of negative. If I approach on the right-hand side, which is 1 to the power of positive. So which means this is the left-hand side of 1. Okay, and then approach to the equation. So sub it in, you still got, right? You got 1 minus 1 is 0. And then limit x approaching to the 1 to the power of positive to this equation. And then you got 1. And how do you make a conclusion? You say, since limit of x approaching to the 1 on the left negative for the function is not the same as limit x approaching to the 1 to the positive of the function, therefore fx is not a continuity function. Do you understand what I'm talking about? Yeah. So the whole thing is, can you able to bring out the limit by yourself? Not bad. The concept is very basic, but majority 70% will make a mistake. Can you copy everything down, including this bit? Angry face, wrong. Then just put a cross, big cross. Give yourself an angry face. And you're able to see, we do it slowly first. We do this one first. Don't use limit to determine continuity. You try to recall what you heard. The hardest bit is I need to use limit. I need to use limit, just these 3 words. What? Come again? Come again?
You meant to use limit.
I meant to use limit, yeah.
But you wrote don't use limit.
No. Oh, sorry. Don't use domain. Domain. Don't use domain. Oh, you're concentrating. Good. Appreciate it.
No. I'll go on, man. Been a bully.
Don't use domain to determine. Whatever you see on the screen, okay? So this is the right-hand side. So you look at that, you say, what do you mean by 1 to the power of negative and 1 to the power of positive? Conclusion, also the same. Learn how to present fx is not a continuity. True. Just 1 mark, nothing much. So you may say, oh, just 1 mark, so what? Or, yep, I don't want to lose even 1 mark.